Hello friends, welcome again. So today we are going to discuss database types and database indexes as well. So if you are new, so this is a system design series. So we have already discussed a lot of system design concepts. And if you're new, then you can go through all the list and see the playlist in my channel, as well as I also paste the notes meaning GitHub notes. If I show you, just like so today we're going to discuss about these databases, and I will prepare the notes for these whatever we will discuss, and I usually update here as well. These are basic concepts, and here we have uh, building blocks. So just like as today, I will create one file and then I will write something like uh, DB concept. Okay. So I will not I'm not gonna write like everything right now. Just I'm showing you. So I will paste whatever data I have prepared here. Okay. So today we are going to discuss SQL versus non-SQL, SQL or SQL whatever, and database indexes. This is our next topic in our system design series. Okay, so let's get started. So I know everyone knows, even the first year of BTech student should know okay what is database, but still it's a kind of revision as well, and sometimes we don't know internal concepts like how internally it works or it designs or whatever, right? So bear with me. Okay. So what is database? Database is like a smart filing cabinet where you store, organize, and retrieve data quickly. Just like you might different use different types of cabinets for different things. There are types of databases like SQL and non-SQL. Okay, so simple, right? I know you know organization of data, right? Organization of data into tables is a database, right? Simple. So this is a kind of explanation with our real world example. Okay. Store organized very quickly like cabinets. Okay. So think of SQL like organized, well spreadsheet Excel where each row and column is fixed. And non-Excel is like a folder of sticky notes or flexible unstructured free form thing. Okay. So this is our kind of one liner definition. Okay. So I will explain. First of all, I'm going with SQL structure. SQL is structure query language. We also known as relational databases. Then I will discuss non-SQL. Okay, okay. So what is SQL? SQL database store data in tables. Right? Like rows and columns in a spreadsheet. Important. Rows and column in a spreadsheet. Okay. Every table has a fixed structure called schema. Every table has a fixed structure called schema, and table can be linked to each other using relationships. Simple definition. Okay. Now, tables, columns and rows. Columns we called fields, rows we called records, keys, and SQL language to query, retrieve, and search data. Retrieve, feed, whatever. Okay. Just like as example, online store. Imagine you run an online store and you would have, first of all, okay, first of all, customers, orders, products, order items, customer details. So in customer table, we store customer details, order info, product details, item in each order. Customer ID, just like as we're gonna store customer ID, name, email, and in order table, we're gonna store order ID, customer ID, date. Okay, who order, the name of the like detail of the customer, because we will fetch everything from this ID. These are kind of primary key. We'll discuss later. Now, product details. This is our product ID, name, laptop, price, this. Now, items in each order. In this order, we have product ID 55, quantity 2. Now, from here we can see everything. Order ID, product ID. Okay, so product ID 55 is a laptop, price this. Who ordered? From order ID we can get order 101, customer is this. From customer ID we can get customer name, email ID. So everything is, we can link everything all together. Okay, this is a well structured example I have created for you. Okay, so these all tables are connected. Our customer have many orders, and one order can have many products. This is called relational structure. One customer has many orders. This will get repeated, and one order can have many products. Meaning this can be, this is inventory. This is inventory, and this will be many rows. Okay, so this simple thing, right? Very simple and easy to understand. Popular databases, just like as generally we, okay, so MySQL used by Facebook, Twitter, YouTube. I'm not sure you know about this thing or not. So Facebook, Twitter, YouTube uses MySQL. Postgres used by Instagram, Reddit. MySQL Server used in enterprise applications, just like as insurance companies like Allstate, uh, they use SQL Server heavily. SQLite, it is used in mobile applications, and Oracle used in banking and finance. So in Citigroup as well, we use Oracle. Okay. So core snippet, simple. To get all orders for a customer, I've written one query for you as well. So you can see, select order ID, product name, order.quantity from. So everything is connected. So we use join. Table 1 on order ID. Okay. Table 2 on product. Simple. And product we have forgot. Okay. So here product we have, and order item has product ID, order ID, and order ID has customer ID. So in this way, we can fetch all the orders ordered by customer. Okay, customer 1 or 101, whatever. So now very important thing, this is a very important. When to use SQL versus when to use non-SQL. We'll discuss non-SQL later. So if your data is structured, won't change shape often. Shape meaning schema. You need strong consistency, banking, hospital, payrolls, right? You need complex queries with joins, cross tables. Relationship between data are important. Okay, the thing is, when you have structured data, okay, we have, you have 10, you have one form with 10 fixed records, right? Then simple, then you must use SQL. And suppose if you have 10 tables, right, and you have to fetch data from each tables. then you have no chance uh, to use non-SQL. You must go with SQL because Advanced and all doesn't supported by non-SQL database. Okay, so pros: high structured, strong consistency, powerful queries, mature technology, acid compliant. But cons, what are cons? Flexibility, less flexibility, hard to change schema later when you will have 1 million records in table, right? Then adding and removing column will be a nightmare. Okay, so can be slow at massive scale, vertical scaling, more powerful server, more money. Okay, so the thing is, we can't scale because SQL will be in a single machine. Like we can scale, we can use like lot of things, server, like uh, master slave concept, but still, everything resides on the machine. Okay, so scalability is difficult here. Okay, so let's go with non-SQL database, non-relational databases. What is non-SQL? No SQL. So no SQL or no SQL database is not does don't use table with fixed row and column. Okay, this is an important line. Don't use fixed row. Instead, data is stored in flexible formatted document. Key pair, graph, wide columns. NoSQL was inverted to handle huge amount of data at massive scale, like social media streaming. Okay, so basically, we store data in JSON format. Okay, just like as if you want to store like 5 fields in one go, you can go with that. If you want a 4 field in another go, it will support. Okay, if you want only store one field, it will also go with one field. So it doesn't care about the fixed structure. Okay, so if SQL is like a printed form, every field fix. Okay, NoSQL like a Word document. You can write what you need, skip what you want. Simple, right? Like this. You can store four values, 5 values, one value, depending on your need. Okay. So types of non-SQL database, just like as here as well for documents, just like as usually, I think you worked on this MongoDB and this Redis. Okay. Oh, you worked on might be Cassandra as well. First of all, Cassandra we were working on, and then we moved to MongoDB. Redis is common, and for our AWS things, we also use DynamoDB. So here for documents, we use JSON-like documents. For key value, simple key value, we use for caching, just like a Redis for byte column, rows with flexible columns, whatever I was talking about. Analytics, IoT, best for analytics, Cassandra, nobody also support the same. Graphs, nodes and edges, social network maps, just like a new for the Amazon Neptune. So now I'm going to show one example for no MongoDB document. Instead of multiple tables, MongoDB store all related info together in one JSON format, just like as here I was showing before. ID, name, email, and in order, you have multiple products. Okay, so everything in a single JSON. Easy, no complexity, no joins, nothing. Notice how one document whole customer and their order details, no one needed. Okay, everything in a single thing. So popular NoSQL databases you worked on for sure. You worked on MongoDB, Redis. Okay, so these are going in our regular databases or regular day-to-day like practices in company or wherever we are working right now. So Apache Cassandra, Neo4j, Amazon Dynamo DB. Here are the examples. So when to use NoSQL. Now we discussed before when to use SQL. Now when to use NoSQL. Your data doesn't have a fixed shape like flexible schema. If you have fixed schema, then you have to go with SQL. If you have non-fixed, then you can go with non-SQL. Okay, you need to scale horizontally, add more server cheaply. So in MySQL, so it's stored in a single machine. Okay, so we can do vertical scaling, meaning we can upgrade the memory or whatever in one machine only. But here we can scale horizontally. It's like as we can add multiple machines because we don't care, right? Suppose here we are pushing 5 documents, 4 documents, 1 document, 3 documents. So we don't care about fixed structure. So horizontal scaling is possible, like easy. You're handling huge data volumes, data fast, real-time applications. Okay, so these are the things when we go with NoSQL databases. Okay, again it has some pros and cons. So pros we already saw flexible schema, horizontal scaling is easy, very fast read write, get from structured data, big, built for big data. Not big data that part thing. Big is like simple large data. Okay. So cons, no strict consistency by default, limited join capability, less mature query tool, risk of data duplication. So here uh, features. So non-SQL versus SQL, data structure, table and rows. Here document key value, fixed stick schema, dynamic schema, structure schema. Relationship strong, joins foreign key weak, don't have joins. Vertical scaling, here we have horizontal scaling. Strong asset base, eventual consistency. Standard SQL varies per database. Best for banking, ERP data structure, best for analytics, big data, social media. Example, MySQL, Postgres, Oracle, here MongoDB, Redis, Cassandra. So we have thumb rule. If you have data looks like a spreadsheet, go with SQL. Data is messy, varied, go with NoSQL. Okay. Now, that was our SQL and non-SQL. I hope you have clear idea. I believe you already know, but right now I hope you get some internal concepts as well. Okay. Now we are switching to database indexes. So what is database indexes? You everyone knows, right? Just like as I just wrote a simple like example here, definition here. Index is a special data structure that makes data faster without reading the entire table row by row. Just like as example of book. Okay, we have index at front page. We can jump directly to particular page if we need to go. Okay, without index, we have to without any database goes with full table scan, check every row. Just like as we have to read all the pages. Okay, and here with index database jump to the directly the data we need fast. Okay, so this was our index definition, and now index how index works. It uses B tree. Okay, most databases uses B trees balanced tree for like structure for indexes. Imagine a binary tree where data is sorted in a way that allows fast searching. Instead of scanning all row, database traverse the tree in a O log n time. simple. If you have to search some, okay, here we have example. I have put look for 60. Now BT, what it does? We have 50. It's greater than 50. Go right side. Okay, otherwise left side we have to go. But here again, 60 is less or uh, more, like large or small. Small, we have to go left side. We found 16, one step, two step. Okay, so only two step. Okay, here we have written as well two step. We found our required value. So without index, check all the 1 million rows. Okay, but with binary tree, it will be only 20 steps. How 20 steps? If we have just for an example, if you have 1 million records, okay, so most probably half million record will be here in left side, half million record will be at right side. Okay, again, around 225, like 2,50,000 will be here, 2,50,000 will be here. Same. 2,50,000 here, 2,50,000 will be here. So like this, we can find in 20 steps. Okay, the value will be log 2 of 1 million. Like, why I'm explaining this? Because this is an internal concept. Okay, more we spend the time, more you understand. Okay, and the search will be fast. Okay, let's go to the types of indexes. The primary index, cluster index. So it created automatically on primary key. Usually, we create one primary key, just like as our order IDs, customer IDs, right? So we generally put the primary key here, and this is a cluster index created automatically. Only one context collection the per index. Okay. Then secondary index, non-cluster index, created manually on manual other columns. Just like as we have email. Okay, we know email IDs are also unique. So we can create one other than primary key. We can create one other index on email ID as well. Okay, so this will be a kind of non-cluster index, is a separate mini table of indexes versus row pointer like index at the back, kind of secondary page index, right? To make our search fast. Composite index, like multi-column. Okay, just like as our first name, last name made one index. Okay, now unique index. Generally, we use unique index as well, just like as I use one example. Non-cluster index, we can create a non-cluster index of here as well, and we know it's a unique, so we can use unique. Create unique index IDX email. This is the name of the index on user email. This is a table name. This is a column name. Okay. Now, full text index. I hope you heard about cluster, not cluster, non-cluster, multi column, many composite index, unique index. But here, some more concepts. Full text search. Suppose then for searching text contents. Okay. Used for search engines, blogs, document search. Suppose we have multiple paragraphs stored or too much data stored, and we search for support contains free text queries. Okay, if we search word database, so wherever the database will be, it will fetch everything. Okay, full text search. Then hash index uses the hash function to store and retrieve data. Extremely fast for exact lookup of one time. Don't support query range this. If you are using the hash index, it will be a equal to sign, right? We will not gonna use we can't able to use this operation. So common in Redis and in-memory databases because we need a particular value, right? So simple. Let's recap. Uh, so index type B tree like balance tree for general purpose queries. Support yes. Hash table exact match. Support range no. Full text search inverted. Keyword search in text no. Like support range no. Composite multi-column B tree multi-filter queries. First column yes. Cluster sorted data primary key yes. Non-cluster separate index plus pointer secondary column yes. So what does mean no or yes? Meaning these has a wide range, right? But these don't have wide range. Wide range meaning we might fetch multiple rows, right? But here particular data we're gonna fetch. So just for an example, I had some queries as well. So for basic index, create index index name on employees and in which column last name. Create unique column, sorry, create unique index name on users where email. Create index name on department cell. Composite index. Okay. Drop index name on employees will drop the index. Explain. Okay. Check if the index is being used. Use explain. Explain and query. Now, darker side of the indexes. Indexes are not free. Okay. So basically these are used for select query. Okay. Select faster select queries, quick data lookups, efficient sorting and filtering, speed of JSON, but slower. Insert update delete this extra disk space used, maintain index overhead, too many indexes, query plan confusion. Okay, when not this is also important. When not to create index for small tables, column with few unique values, just like as male female, table data updated very frequently, commonly rarely used, where or joins. Okay, then you don't need to create indexes. Now just a quick recap. We learn SQL, NoSQL. SQL is structured, fixed schema, great for relationship and consistency. NoSQL, flexible structure, scale horizontal, great for big data, varied data. Nothing is better. Choose based on your use. Okay. Database indexes. We learn indexes, shortcut of data structure to find data faster. Binary tree. Indexes are most commonly sorted support range. So types of indexes secondary, secondary meaning non-clustered, composite, unique, full text, hash. Indexes speed up read but slow down writes. Always checks on pattern before adding indexes. Okay, so these were the details for SQL and NoSQL as well as database indexes. So I'm wrapping up this video now. If you have any questions, then please let me know. So bye for now.